Okay, hello everyone. I have come with the very last lecture in the series of chemical reactions. So this is going to be the last lecture in this chapter for this chapter. So from the next class we'll start up with another chapter. So let us quickly wrap up this. Actually this should have been dealt earlier, but I felt that now it is now you are in a state to understand these things better. We'll discuss about the characteristics of a chemical reaction. Obviously, first one is change in state, isn't it? That is a very special character of a chemical reaction. Hydrogen, you can see here, hydrogen, which is a gas, combines with oxygen, which is a gas, to give water, which is a liquid. So you can see there is a change in state. So a chemical reaction, you can see a chemical reaction followed by a change in state, isn't it? This is the first characteristic. Second characteristic, change in color. Iron plus copper sulfate gives iron sulfate plus copper. Obviously the blue coloration of copper sulfate fades away and a brown coloration is formed due to the formation of iron sulfate. Okay. Similarly, evolution of gas. Zinc reacts with sulfuric acid to form zinc sulfate and hydrogen you can see is a gas. उड़ के चला जाता है. This arrow represents that gases are volatile, isn't it? Another one is change in temperature, and this is very obvious, isn't it? After a reaction, obviously the temperature will change, isn't it? The reaction initially, the temperature initially and after the reaction has completed will not be same. There will be an alteration in the reaction. We have already done exothermic, endothermic reactions, isn't it? So this part is clear, hopefully. Now next, which is very important from an examination point of view, and I've seen that this is frequently asked in examination. First of all, corrosion. Okay, what is corrosion? Corrosion, you have seen, no, metals. Once you buy the metals when it is new, any object which is made up of metal, when it is new, it looks very good, shiny, nice, polished, isn't it? With passage of time, it starts appearing dull, isn't it? It starts appearing dull. How does this dullness creep in? Why does that happen? Isn't it? Most of you may be knowing, isn't it? Iron, rusting, you all say. Rusting, that is called rusting. Okay. Now, there is a more, technical term given to that phenomena, that is called corrosion. Now, corrosion is the depletion of the metal. Why metal? Have you seen water getting corroded? Have you ever seen water getting corroded? No, water will not get corroded, isn't it? Why it will not get corroded? Because it is a combination of gases, isn't it? So basically what happens is, this is seen only in metals. Majority of the times it is seen in metals. Why it is seen in metals? Because metals are very reactive. Very obvious. It's very obvious. How reactive it is a metal? It will react with the, atmospheric oxygen, moisture, isn't it? And whatever is present in that water vapor, isn't it? Whatever is present in the atmosphere. So due to reaction of the as the metal reacts with the constituents of the atmosphere, oxidation process creeps in. So that eats away the the layer, upper layer of the metal, isn't it? So there is a gradual depletion in the surface of the metal. So that is termed as corrosion. Okay. So basically what is happening? Oxidation is happening. Where is it? Oxidation. Now we have taken the example of iron, which is the most obvious example. Corrosion in iron is called rusting. That everyone knows. Corrosion is a technical term which signifies all the metals. But if we come to iron specifically, it is called rusting. Okay. For example, iron, you have seen iron nails getting rusted here and there, thrown here and there, isn't it? So iron reacts with atmospheric oxygen and moisture present in the atmosphere to form hydrated iron oxide, Fe2O3.XH2O, hydrated iron oxide, and this hydrated iron oxide is your rust. Basically, the formation of oxides and hydroxides on the surface of the metal, isn't it? That is what is being seen on the surface of the metal, and that is responsible for the dullness of the metal. That is what is being formed. This chemical compound is being formed on the iron surface, so as a result of which it is appearing dull and sort of hazy, and it does not look good, right? So to prevent it, we do coating and we try to do the greasing and all. We do galvanization and all. Those are different techniques of preventing rusting or corrosion that we'll discuss when we'll discuss metals and non-metals. Okay, so hope this is clear. Hydrated iron oxide. Basically, oxides are formed on the surface of the metals, which results in this corrosion process. Now, next is rancidity. No? Your mom must keep the edible food items, isn't it, in airtight containers. The pickles and all, isn't it? Airtight containers, and even the food which is left over at night. If you want to take it in your breakfast, which most of us do, obviously I do it. How is it stored? It is stored in a very safe manner, isn't it? So that food does not interact with the atmospheric oxygen and other chemical compounds which is present in the atmosphere. Basically, what happens is whatever food items we prepare, they contain fats and oils, right? Isn't it? They contain fats and oils. So these fats and oils, if they are exposed to the atmosphere, okay, if they are exposed to air, light, and moisture, they start reacting with it and they get oxidized. Okay, so after oxidation, after the reaction has undergone, it will result in an unpleasant taste and odor. Obviously, it does not smell good, right? If it is if it has already oxidized, and that is happening because of something known as rancidity. And what is rancidity? It is the oxidation of fats and oils. So it will have an unpleasant taste, and obviously we'll throw it away. And there are a lot of ways to prevent this. Obviously, we keep store the food items in a safe manner so that it does not interact with the atmospheric constituents, and obviously you store it in refrigerators and so on and so forth. You store the pickles and all in airtight containers. And obviously, one very simple method which is used by chips companies, Lay's, Uncle Chips, and whatever what else, Bingo and all. They have been successfully selling air for so many years, isn't it? Chips, we have so less chips and so much of air filled within the packet. Why they are doing that? Because they want to keep the chips fresh for a long interval of time. So what they do is they introduce nitrogen gas into it. Nitrogen gas. So once they introduce that nitrogen gas, it will prevent the chips, which is made up of fats and oils, to undergo oxidation. So as a result of which, that chips in the packet will not undergo this oxidation process, and it will not and it will it can be edible for a long period of time because it does not undergo rancidity. Okay, so with this I think we have completed this chapter. So in the next class I'll start up with another chapter. So see you there. Thank you.